Yeah. So in the last videos, I think we started our first chapter, which is nothing but introduction to data structures and algorithms. Introduction to data structures and algorithms. Here we have seen the basic. Suppose if you are getting any problem, how you can able to solve that problem. What is the idea behind that, and how to generate the algorithm for that problem, and how to write a flowchart, and how to implement a program like in depth we have seen very clearly in the last videos. Now, sir, we have discussed in detail about what is mean by algorithm. Algorithm is nothing but what a step by step process to solve a problem is called as an algorithm, and we have seen some example also related to that. So next and after that we discussed about the flowchart also. What is mean by flowchart? So for the given algorithm, how to generate flowchart. Next and after that, even we have seen implementation of that particular program. Suppose if you have a problem statement, so once if the algorithm is ready and once if the flowchart is ready, so how you can go for the implementation, that part also I covered very clearly. Next and after that, we implemented the program in Python. Then we have seen what are the advantages are there for algorithms, and what are the various properties are there related to the algorithms, and different types of algorithms also we have seen very clearly in the last videos. Now we are going to talk about data structures. What is another part in this, sir? Data structures. See what is mean by data structures. As you know that data structure is nothing but what organizing the data, so present in a database or file or anywhere. So organizing the data is nothing but data structure. Okay. So collection of data in organized manner. In a organized manner means what? So different data structures are going to follow different styles, or different techniques will be there for organizing. For example, if you take a stack is going to follow one structure. If you take to follow one structure, okay. If you
Sir, your voice is cracking, sir.
Voice is breaking.
are taking linked list, yeah, just 1 second, I'm changing the network. Please wait. Yeah, is it clear now? Please confirm.
Yes, yes.
Yes.
Right, sir. Right. So data structure means what? It is nothing but what? A collection of data in a organized manner. See, we can perform various operations on data structures. The following, the following are the very common operations that can be, okay, that can be performed on data structures, that can be performed on data structures. Sir, what operations that we are going to perform? Very common operations like inserting, inserting a data into inserting the data into data structure, like different techniques will be there, right? Okay. Sir, when class is going on, please concentrate on the class. Don't put any other relevant messages in the chat window. So because we are going to disturb. So whenever I'm getting a message, I'm going to check whether my voice is audible or students are facing any issue. Okay, like that. But if I open that, I'm going to get, sir, I'm not having any WhatsApp group. I didn't added you WhatsApp group. Okay, running notes yet not shared, videos are not shared. These things at the end of the class we will discuss. Okay, please concentrate on the content because I'm there. I won't leave you. Okay, definitely I will give access for everyone. So these things we can discuss at the ending, sir. Please concentrate on the content, whatever we are discussing. Okay. So inserting the data, what are the common operations that we can able to perform? Insertion operation. Then even we can perform delete operation. Even we can perform delete operation and searching operation. How you can able to perform searching operation? Then sorting operation. How you can able to perform sorting operation? Okay. So like this, finding the maximum element, minimum element, like n number of operations are there. These are nothing but the very few operations that we can able to perform on the data structures. If you take any data structure, these operations we are going to perform very casually. So this is nothing but what we have. So next and after that, these data structures are classified into two types. These data structures are classified into two types. What is the first one is nothing but what? Linear data structures. What is the first one, sir? Linear data structures. And the second one is nothing but non-linear data structures. What is the first one, sir? Linear data structures. And the second one is nothing but what? Non-linear data structures. Like this, we have two divisions. So this is nothing but what we have. Let us see in detail about linear data structures and non-linear data structures. So if you take linear data structure, what is the meaning of linear? Can I say, is it a continuation memory locations or not? Yes. In the case of linear data structures, the data will be organized in a continuous manner. In a continuous manner, this data will be arranged, sir. Okay, continuous manner, continuous memory locations will be there. And if you take non-linear data structures, so random memories will be there. That means what? Suppose consider I want to insert the data like 10, 20, 30. So there are two ways are there. In the first way, what will happen? A box will be created like this. Here 10 will be allocated. In the very next location, 20 will be allocated. In the very next location, 30 will be allocated. This is one style. What is another style? Sir, 10 will be created here and somewhere the data 20 will be there and somewhere the data 30 will be there. But a link will be there between these. Okay. So do you know this data structure is commonly called as either list or we can use the word called array. And this one is, we know very well, linked list. Linked list. Sir, in the list or array, can we insert the elements? Yes. Can I delete the elements? Yes. Can I perform search operation? Yes. Sorting operation? Yes. In the case of linked list also, same these operations are applicable. See, there are some more data structures are there. Of course, linear only, but you can see queue. Queue is there. So queue means, for example, if the first person came into the queue and the second person came here and the third person came here. So the person who entered first into the queue, that person is going to get highest priority. Something like a first in, first out technique. Okay, and there are some more data structures are there like a stack, where if you are inserting any element, that element you have to access first. So remaining elements you have to access next. Like that, it is called as what? LIFO technique. Like we have various data structures are there, but all these data structures are classified into two categories. One is nothing but linear data structure, and the second one is nothing but what, sir? Non-linear data structure. Linear means what? The memory will be stored in a continuation memory location. Whereas coming to the non-linear, what will happen? In a random memory location, it is going to be stored. I think you got clarity at a top level. What is this linear data structure and what is this non-linear data structure? Can you please confirm if you are clear with this? We will see one by one data structures, sir.
Sir, in linked list sir, linked list come under linear data structure category, na?
No, no. By
Sir,
using, yeah, you can assume by using the links, So if you are asking 10 and 20, is it in a continuous in memory location? Means we can't give guarantee because 10 will be available somewhere, 20 will be available somewhere. But how we are connecting these two? We are connecting via link. So, okay, if you see that linked list, what is the purpose of linked list? So to make a continuation only, we are going for this linked list. Are you observing at top level?
Yes, sir. But sir, in
Hmm.
Python there is there is nothing concept like a pointer. So means in which concept we can give consider into a linked list that with respect
No,
to
when we are creating a new object, whether it is a Python or any language, when you are creating an object will be created, right? Suppose if
right.
I'm creating next node, we can't give guarantee that that node will be created next to the first node. We can't give guarantee, right?
Yes, sir.
Are you getting
So
my point?
yes, sir.
So
So we are storing.
through the links only we are going to connect those two. Suppose consider 10, 20, 30 is there. So we have an option. Is it possible to insert in between 10 and 20 a new node? Yes. If you insert that new node, after creating 10, 20, 30, we are creating a node 40. But we are inserting that 40 into in between 10 and 20. So seems to be it is something like a sequential manner, like 10, 40, 20. But physically, sir, is the 40 is having continuation memory location? Like after 1040 is created? No. Are you getting my point?
Yes, sir. Means the reference is given to a node so that
Yes. Yes. With respect to memory, I classified these two types, sir. With respect to memory, I classified these two categories. Okay.
okay, fine.
Yeah. Right. Please confirm everyone. Is the concept is clear, sir? Up to this, whatever I covered. Right. So next, can you please tell me some data structures that you know, some list of data structures, examples for the data structures if I want to provide. Can you please tell me some list, sir?
That queue linked list
Yes, very good. We have
hashing.
arrays are there. Can I say this array in Python is represented as a list or not? Yes.
Definitely.
We have string is there, and we have stack data structure is there. We have queue data structure is there, and we have priority queue data structure is there. Next and after that a linked list is there. Next and after that a tree data structure is there. Next and after that a graph is there. Next heap data structure is there. Okay. So next and after that hashing is there, etc. These are nothing but various data structures which are available here. Okay. So many data structure, even hash table, like all these things we are going to cover. Just I am representing at the top level, sir. Okay. One by one, just a basic definition, how it is going to work. These things I will cover one by one. Sir, can you please confirm? Is these examples are clear for you people, friends? Yes, please confirm everyone. Are you clear with this?
Yes, sir.
Right. Let me talk about the first one. What is the first data structure that we have here is array, or we can use the word called list. Sir, what is mean by this array or what is mean by the list? Very simple. I can say it is nothing but something like a collection. It is nothing but what? So collection of similar type of elements. Similar type of elements. If you collect similar type of elements into a category, then it is called as what? Array or list, collection of similar type of elements. But sir, in Python, list means different types of elements also, right? But in the array, similar type of elements will be there. That's why, so for array, I am going to use this definition. But for list, what definition I can able to say, sir? So it is nothing but a collection of different types of elements. But generally, we want to go for different types of elements. Better to maintain homogeneous elements, like generic types you have to define. That we will see later.
Sir, I have a doubt.
Next. Yes.
You told array is a collection of similar type of elements. Are you pointing to NumPy array?
No. Generally, I'm not
General
talking
array.
with respect to Python. I'm talking with
Oh.
respect to the general terminology.
Oh, okay, got
See
it.
here, Python will come only when we are implementing the code.
Mm-hmm.
So rest of the things is independent of Python. Are you getting my point?
Okay, I
So
got it.
yeah, data structures is a is separate concept. We won't include with Python. But when we are talking about the working principle of that data structure, then only we will introduce Python only for coding. Okay,
Got it.
right, sir. Good. Next, and here in the array, or if you take a list, so index concept will be there, right? Index concept will be there. So index concept is allowed. So whenever you are taking index concept, do you know almost all the operations, almost all the operations are required. So big O of big O of one unit time it will take. Means what? Suppose if I want to insert an element, sir, at the beginning I want to insert an element. Simply, we are not required to disturb the list. We are not required to disturb the list. Simply, we can add. I want to add at the ending. Simply, you can add at the ending. Sir, I want to add at a particular position. Happily, you can do. Okay. And sir, if I want to perform search operation, it will become some time. Time must be required for that. But that's what I'm telling. Almost all the operations, but not every operation. Maximum operations are going to require only big O of one time complexity. So this is nothing but when compared with other data structures, it is a somewhat best. But we have some disadvantages also there in these data structures. So processing of this data structure is very difficult. Suppose consider I want to maintain something like a reservation system. So the person who is coming first, we have to give first priority. Sir, can I process that by using the list or array? No, we have to go for some priority based things. That's why in such cases, it is not recommended. Okay, the problem with is nothing but length is fixed. But when we are talking about the list, especially in Python, it is not fixed. It is a variable length that we will discuss later. And what operations we are going to perform on the list, sir? Sir, do you know we can perform insert operation? We can perform delete operation. We can perform accessing the elements present in the list. We can perform update operation. We can perform sorting operation. We can do searching operation. Like all these operations, happily we can perform on the list data structure. That is nothing but array. Okay, so inserting means what? We are going to get a new object. We have to insert that object into the array. And in the case of delete, I'm going to get one object, I have to delete. Suppose in the case of this accessing, I'm going to give an index array, can you please get the third element? Yes, happily you can able to get. And the length is always fixed here. Okay, so that's why we can't able to perform insert and delete operations in array, but we have ready-made methods are there. By using that, we can get where a new reference will be created and old elements will be copied into that. But don't worry, all this stuff we will discuss as a separate chapter, but see at the top level. Next, sir, one more data structure is there related to this, which is nothing but a string data structure. Sir, what is mean by string? In my point, can I say, is it a group of characters or not? Yes, group or collection of characters is called as what? String data structure. A group or collection of characters. It is an object. It is an object. So in Python, it is treated as what object, sir? Okay, and it is also works based on index concept. Based on index concept only it is going to work. Okay, so this is nothing but what we have. And what are the various operations that we can able to perform? We can create a string object, and whenever you require, you can insert some characters into that. And if you want, you can access the elements present in the string. If you want, you can perform update operation. If you want, you can perform delete operation. Okay, so if you want, you can perform delete operation. Like various operations we can able to perform on string data structure. We can perform various operations. Sir, can you please confirm? So do you have any doubt about this array data structure or string data structure? What is mean by object in Python? Okay, so as a Python student, you should not ask this. Object means what? Everything is treated as object oriented programming in our Python. So even in Java also, how to create strings? So string s is equal to, we are creating new string like this. where S is nothing but an object. In Python, how to create a string? For example, if I am taking like this ABC, it will create a new object with the content ABC, and S is the reference variable pointing to this. Even in Java also, it will create a new object and it is going to point reference variable by S. Sir, please confirm everyone got the concept about this array or list and then string.
Yes.
Any doubts? Clear, sir? Please confirm everyone. Sir, please respond. If you are clear with this, I will go for next concept.
Yes, sir.
Yes, sir, clear.
Right, sir. Just give me 1 minute. I will be back. Please wait 1 minute. Yeah, right, sir. Let us continue. So the next data structure, what we are going to see here is linked list. Linked list data structure. I think we have seen the demonstration how the linked list is going to maintain, right? So can I say linked list? It is a collection of nodes. Nodes means what? Either it can be a single node or it can be a double node. It can be a single node or it can be a double node. So we can say linked list is nothing but what? It is a data structure which is nothing but a collecting some nodes. That node can be either single node or double. So I think if you have seen the demo sessions there I covered. So single node means what? It can contain two fields like a data field and the next field which is pointing to the next node. And that if you take a double node, three pointers will be there. One is a previous pointer, another one is nothing but a data pointer, another one is nothing but next pointer. Like this we are going to have. So linked list means what? It is nothing but a group of nodes, collection of nodes. So where it will be a single node, it can be either single node or double node. If you take single node, then data and the next field will be there. If you take double node, previous field, data field, and the next field will be there. Like this we have. And in our program, especially in our Python, this DSA, we are going to talk about a single linked list. It is in short form, it is called as SLL. And we are going to talk about double linked list where it is called as a DLL. And we are going to talk about a circular single linked list where it is called as CSLL. And we are going to talk about a circular double linked list, where it is called as a CDLL. Like this, we are going to represent in different data structures. I mean, different implementations. Sir, what operations we are performing on this linked list? As usual, sir, insert operation, inserting a new node into the single linked list at a very beginning location, at the ending location, or at any location whatever you are giving, like that. Okay, similarly, delete operation will be there. We can perform delete operation, and we can perform traversing means what? Visiting the nodes. And we can perform find operation, like whether the node is available or not. It is also called as search operation. Suppose I want to find out maximum element or minimum element in the nodes, then I want to perform update operation. So like we have various operations are there that we can able to perform on linked list. I think in the demo sessions I explained a PDF I have displayed, right? We are going to perform various operations on this. Okay, so this is nothing but what is linked list data structure what we have. Can you please confirm everyone, is the concept of this linked list data structure at the top level? Is it clear for you people?
Yes, sir.
No, sir. I have a doubt.
Yes.
See, then what is the difference between linked list and list? What extra thing is there in linked list?
Linked list, see, you are talking with respect to Python, right? So Python is having inbuilt data structure called list. So internally, how this list is implemented? By using linked list concept only. We are going to see how internally it is going to work. But a ready-made support is there for you like list. That's why you are getting confused. But internally, how list is implemented? By using this linked list style only. Even in Java also, we have a linked list class is there. Directly, we have a class. But internally, how it is implemented, we don't know, right? That part we are going to discuss.
Second question. This node you are telling, nodes. Okay. So, node, then you are telling single node data and the next means it will be, there will be two box. One box will be having data, another box will be blank or something like that, right?
No, it is pointing to the next node like that.
Next node. Oh, means next means like suppose there are 10 and 10, one blank space, and 20 and one another blank space. So the
10 blank, 10 blank space is there, right? That will be connected to the 20.
20. Okay.
And the 20 blank space will be connected to the next node. If there is no node, it will be pointing to none. Sir, we will see in detail. Don't worry.
Okay.
Again, someone is asking, sir, it can be a continuous location in the memory. No. I told already, whenever we are creating a node, so we can't give guarantee. Sir, why you people are getting confused? Whenever we are creating a new node, okay, we can't give guarantee where it will be created. In the memory locations, can we give guarantee? No. So, but in the case of list, how list is implemented? Suppose if you are creating a list like this, then what will happen? So it will create an empty list. Whenever we are adding 10, and then we are adding 20, and then we are adding 20, 30, we can't give guarantee. But at the very beginning itself, if you are creating a list like this, then what will happen? So these three data continuously we created, right? So continuous memory locations will be there. That's why please don't get confused. As of now, linked list means what? So the nodes will be there in the random locations. We are connecting one link with one node with another node. That is the reason why the name came like linked list. There will be a link between two nodes. Got it, sir? Everyone please confirm. Is it clear?
Yes.
Right. Sir, next data structure, I think you know about this one very well, which is nothing but a stack. If we are talking about a stack data structure, sir, what is a stack? Can I say it is a special data structure? It is nothing but a special a special data structure. It is a special data structure that follows. Everyone, can you please tell me which strategy it is going to follow, sir?
LIFO.
Very
LIFO
good.
fashion.
Yes, LIFO strategy it is going to follow. Sir, what is mean by this LIFO? What is the mean by this LIFO? Very simple, sir. Last in, first out. Last in, first out. So the element, so that is added at the last term, so will be first removed. First removed. The element which is added at the last term will be first removed. And what operations we can perform on this? I think technical terms you know very well. The common operations that we can able to do on this is nothing but push. Push means what? We are adding an element into the stack. And we have pop is there. What is mean by pop? We are removing one element from the stack. And we have peek is there. What is the meaning of a peek? Sir, we are going to get the element which is ready to remove or ready to access. Okay, sir, similarly we can perform search operation. Okay, like this we can implement various algorithms on the stack, sir. What is the first operation? Push. The people who don't know about the push or stack, the push operation is something like insert operation, and the pop operation is something like delete operation. So peek operation is nothing but something like returning the top element. So search operation is nothing but as usual operation. Okay, this is nothing but a stack. There are n number of applications are there based on this stack. There are n number of applications are there that internally we will see in depth in the stack data structure. And coming to the next data structure, what we have here is nothing but a queue. Sir, what is this queue? Can I say it is a special data structure? It is a special data structure. So which follows? Okay, which follows? Yes, very good. FIFO strategy or FIFO technique. What is mean by FIFO? So the item, okay, the item. So which is inserted? The item which is inserted first will be the item removed first. Will be the item removed first. The item which we are inserting first is nothing but the item which we are going to remove first. Like this, we have this queue data structure. Okay, sir. Next, do you know here we are going to perform some basic operations on this. We don't have any terminology like something like what you can call a push like that. Here direct operation is there called insert, and we have one more operation is there called delete, and we have one more operation is there called easy empty. Okay, so like this we can able to check. Okay, so even we can get a size of the list like n size of the queue. Like this n number of operations we can able to perform on this queue. Sir, please confirm what is this stack and what is the internal technique that stack is going to follow. What is mean by queue? How internally this queue is going to work? Is these two concepts are clear for you people?
Yes, sir.
Please
Sir.
confirm everyone.
Yes, sir. Yes, sir. Sir, but in stack, one operation we can perform, one edit key we can perform, that is pop. Sir, is it similar to the string or in whatever we are performing with string and list, like l.pop? So
That
is
is
it
not string, that is list.
yeah, but we
Yes.
can also perform
Yes, we can do that. Even see, the list is nothing but I told already, something like it is a linked list, right?
yes, sir. So,
Okay,
sir,
in the
in
link,
this,
yeah. I will give the answer. First, you can listen, then you will get clarity. In the linked list, there are some operations are there. What are the operations? Are insert at first. Second operation, insert at last. So third operation, delete at first. So fourth operation, delete at last. Sir, now insert at first. Okay, insert at last, and so insert at last or insert first and delete last. Can I say is it the mechanism of stack? So insert at first and delete at first. Can I say is it the mechanism of queue?
Yes.
Yes, if you take list, especially in Python, I am talking. if you perform append operation and the combination of pop operation, do you know it is called as stack, sir? Because append operation, where it will add always at the ending. If you take pop operation, where it will remove, by default it will remove at the ending. And if you
But
want to make this list as a queue, so in the place of append, we can use append method only. And pop of 0 we have to take. If you take pop of 0, then what will happen? It is trying to add at the ending but removing at the beginning. So the first appended item will be removed first. In this case, the last appended item will be removed first. If you want more clarity, it is -1. The item which is present at the last index, it will remove. Here, the item which is present at the first index, it will remove. Sir, everyone got clarity about this?
Yes, thank you.
okay, so sorry. Okay, so delete at first will be like pop off the index, right?
Delete at last, yes.
First, last will be like -1. First will be like the
0.
index 0.
0.
Got it.
So that index is optional. If you are not giving that index, it will delete at the last. Right,
And
sir.
sir, with respect to Java or with respect to C programming, the terminology of queue operation is different. Like here you are saying that is empty or insert or delete. So on that means on that language we are using like enqueue and dequeue.
There we are using increment decrement. Here also we will use that option. We have various ways are there for implementing these stacks and queues. One is normal, by using some pointer variable we are going to do, and by using some linked list representation also we will do. So here also we will implement all the operations. Just I have explained for your understanding purpose. Okay.
Okay, sir. Thank you.
Yeah, from outside you have to see, that's all. But internally what is happening? We have a separate chapter is there for each and every data structure. There we will perform various operations. Suppose in your mind you got a new operation, sir, I want to do this. Yes, if it is workouting, happily we can able to implement. There is nothing wrong in that. Okay.
So sir, you are right now, sir, you are giving sign-ups of the entire data structure.
Yes, I am giving just what is the technique and how it will be useful. That's all. Only at the top level I am explaining, because introduction theory part, right? In depth, we will see every data structure one by one. Okay.
What?
Can I go for next one?
Yes, sir.
Yes.
Right. So almost majority we covered. So next, what is the next data structure here we have? Sir, do you know tree data structure? I think you heard about this name, right? Tree data structure. Sir, can I say it is a tree is a hierarchical representation, right? Okay, it is nothing but a hierarchical representation, hierarchical data structure. Yes, it is also a kind of linked list only, sir. Okay, so in it is a type of double linked list. It is a type of double linked list. So that means what? Double nodes will be there here. Double node will be there. So double node means what? In general, we are going to talk previous field, data field, and a next field. But here, previous field will won't be there. Here, left child will be there, data field will be there, right child will be there. Okay, and there is one top element will be there. That top element is called as root, something like that we have. And what operations we can perform on these? We can do insertion of a new object. We can perform deleting the object. We can perform search operation. We can find maximum element present in the link in the tree. We can find minimum element, and we can delete leaf nodes. Okay, like we have various operations that we can able to perform. And in our syllabus, we are going to talk about tree data structure. Okay, tree data structure, and we are going to talk about the binary tree data structure. Okay, so then we are going to see binary search tree data structure. Then we are going to talk about AVL data structure, and I told maybe B trees or B plus trees, any one another data structure I am going to explain related to the tree. Okay, just visualization wise, if you want, sir, you can see like this: a data structure will be in this format. Like this it will be there. Sir, it is something like linked list only, but the way of representation is different. Sir, please confirm everyone. Introduction related to this tree data structure. Is it clear for you people, guys?
Yes.
Right. So let us go for the next one, sir. What is the next data structure here we have is nothing but a graph. Okay. Sir, what is mean by this graph data structure? Very simple. I can say it is also, okay, it is also collection of, it is also collection of collection of nodes. Sir, I can say it is a tree. It is a tree with the cycles, with the cycles. In the tree, cycles won't be there. Okay, but if you take a graph, cycles will be there. That means what? So we are going to have which element is the first element. So which element is the next element, and what is the connection between first element and second element? Like that, a connection will be there, sir. Okay, that is called as a cycle. Where you have started, you can visit to the same area again. Sir, something like if you want to understand this graph, very best example, you can see the Google Maps. Google Maps, you can imagine that is nothing but the best place to use this graph. So in the Google Maps, what we are going to do, I think if you remember, we are going to take starting city, ending city. We can travel with the cities. So one place to another place. Suppose if I want to travel from Hyderabad to Bangalore, do we have only one path? No, sir. We have multiple paths are there. But in these multiple paths, which path we will select? So based on the number of kilometers, so which is going to take less time to travel. Like we have n number of options will be there. Among those options, we are going to select one, right? Some parameters will be there, which is going to take a long time, which is going to take a short time, something like shortest path. All these things we are going to see in this. Sir, what are the common operations that we can able to perform in this? In this also we can do insert, we can do delete, we can perform search operation. Do you know some traversals are there? There are two special traversals are there, like BFS and DFS. We will cover with various example algorithms we will see. This is nothing but what is called as a graph. Sir, next we have one more data structure is there, which is nothing but priority queue. Priority queue. Sir, I can say it is nothing but the same like a queue. Whatever queue we have seen, it is a same like a queue. It is a same like a queue. It is same like a queue with some priority. Sir, for example, you can see the traffic signals. Okay, in the traffic signals, what will happen? The highest priority vehicles are going to move first. Even in the doctors dairy, okay, if they have already having some list of patients to be visited, suppose 10 patients are there, so that the doctor is going to come to the office at 11 o'clock and he has to visit all these 10 patients today. Suppose when doctor came at 11 o'clock, some emergency situation came. Sir, is the doctor is going to put that queue outside and then he is going to take the charge for first emergency cases. So in the queue also, sometimes the person who is having highest priority, we have to give the first place. So for that, we have to go for which one, sir? Priority queue. Okay. And these priority queues will be implemented by using heap data structure that we will see. Sir, it is same like a queue. That's why insert operation, delete operation, remove operation, everything will be there. So insert operation, we can perform delete operation, we can perform search operation. In addition to that, so heapify option will be there. Okay, heapify option will be there. That we will see in depth, then only you will get the clarity. And the last data structure, which is nothing but hash table. Hash table data structure is also there, sir. Sir, do you know it is also similar to the arrays? Okay, it is also similar to the arrays. So it is a special, it is a special data structure in So real world, in the real world, it is a special data structure what we have. Of course, in this some problems also there, but still we are using this hash table. Sir, it maps keys with values. The people who are coming from Python background, it is something like a dictionary. Okay, so it uses hashing techniques. It uses so hashing. It uses hashing technique. Okay, sir, what operations we are going to perform here also? Insert operation, delete operation, search operation, like this various operations we can perform. So these are nothing but the different data structures which we are going to cover in our syllabus. Please confirm everyone. Do you have any doubts up to this, whatever I covered?
Yeah, I have a doubt. So that is why the keys can be tuple, because tuple follows hashing, right?
Yes, sir.
Okay, got it.
Sir, clear everyone, please confirm.
Yes, clear. I have a doubt. All the data structures which has been mentioned now by you, every data structures we will be going through the details about all the data structure as well as the problem solving also, right?
Yes, sir. Right. Now, so with this, I'm going to stop today's session. Sir, what things we discussed in the last two classes in the first chapter? Algorithm, flowchart, implementation, and what are the various properties of algorithms are there. Next, and after that, advantages of algorithms and the types of algorithms. And we have seen today what is mean by data structure, classification of data structures. In this, we have seen linear data structures, non-linear data structures, stack. Okay, next and after that, queue. Next and after that, a list or array. Then we have seen string, linked list concept. Next and after that, so priority queue, hash table, then tree data structure. So graph data structure, tree data structure, graph data structure. So these details just at the top level I explained. Okay, tree data structure, graph data structure. So these things I explained at the top level. Sir, tomorrow also same theoretical part will be there, where we are going to talk about the approaches to solve the problem. We have some 5 steps will be there. So those 5 steps we will discuss in the tomorrow's session. Sir, regarding running notes, I will upload, sir. Don't worry. Today itself I will upload, because just now I got the mails for the students who registered into our batch. Today I will upload. And sir, we will create a WhatsApp group. So please share your details, like what is your name, and your registered email ID, and please mention your batch title saying so DSA with Python batch 4. Please mention this batch number also, and with this information send a WhatsApp message to this number. So 7386 237319. This is my contact number. You can save this contact number and send it to me. So we will create a WhatsApp group in this. Okay. Yeah, today I will upload the running notes, sir. I will give access for everyone. Don't worry at all. Okay, I'm going to give access for everyone today. Don't worry at all. Okay. Right, sir. Thank you. See you on the tomorrow's class as usual, tomorrow evening at 7 p.m. Okay. Right, sir. Yeah, thank you.
Yes, sir. Thank you. Bye.
Yeah. If you want to just take a screenshot of this number, otherwise it will be there in the running notes.